Yeah, I'm very honored to be here today. My name is Yuki Maehara. I'm working for SLB based in Tokyo. And today, I'm going to talk about, how, like fracture is evaluated by using borehole data. So I'm lucky because, right after Tito, it's basically, very continuous story. Basically he's talking about a lot of geology, and I'm talking about more like detail how to evaluate, like a fracture by using borehole log data. But unlucky part is, my presentation is right after such powerful presentation from Tito. So please expect, your expectation is, adjust to my presentation. Also, another lucky part, I have my colleague to co-present today. He's a Chin Lee. He's working in SLB in Taiwan, Maehara. So I'm, present together with him. Okay, let's begin. So as here, everyone knows about, geothermal, and everyone is expert. So we have a multiple different type of, geothermal reservoir type, like, sedimentary, basin, also conventional hydrothermal system, and, next generation geothermal, EGS, AGS, like closed loop, right? So by just looking at this illustration, you can see that in reservoir part, like a lot of fractures, sedimentary part and, conventional geothermal part. Basically, we need to understand how Tito also presented. We need to understand, how, fracture it is, because, we need to have fluid flowing in through the reservoir, through the fracture. On the other hand, next generation geothermal, we don't have fracture here, but we need to understand fracture. Why? Because, natural fracture for fracturing, hydraulic fracturing, makes some, sometimes harmful. So before hydraulic fracture design, we need to understand how, natural fracture is distributed. And same things happen to closed loop. Because if you have, natural fracture to permeable, your, fluid circulating this closed loop will be, leaking out. So this is why, even though for next generation geothermal, it is very important to understand how, natural fracture is distributed. So, how we can do that? But we have actually, a lot of challenges. As Tito said, we have like geology complexity. This is very generally, any fracture reservoir, we have a lot of heterogeneity. Like, when you have a drill here, you have nice in production, but doesn't mean next location have also like a nice, production. It's very heterogeneity. Why? Because, fracture distribution is, caused by a lot of different geological reasons. Some fracture is initiated by fault, or like bending stress, or, sometimes intrusion. Unless you understand all this, all the elements, you don't have a, big picture of, fracture distribution. So how we can tackle this, challenge? We need to have data measurement. So in terms of, data, I split into two types of data here. Like one is borehole data, such as like a variable logging data, coring data. So the other side is surface data, such as geophysical surface survey data, such as magnetotelluric or seismic, to understand wide area of, geological structure. So to combine this, we can make fracture modeling for subsurface. Then we can design where we should drill, which azimuth, how deviation. And by having this modeling, we can reduce the uncertainty from the geology. So now today, we are more focused on like left side, borehole data. So like a borehole data here is, I'm more talking about the variable logging data. Today I'm going to focus. This is a typical logging program for the geothermal reservoir characterization purpose. Pressure temperature spinner, which is fundamentally we need to measure temperature in downhole. And gamma ray resistivity, this is crucial for the, fundamentally we need to have depth control. And borehole image log, sonic log data, and density. This is more for, fracture understanding and resource evaluation. So, how this, logging measurement works, I pass to, Tian. Okay.
Hello. So my name is Chingan, and I'm one engineer here in Taiwan. So as you can see, like most of the open hole logging for those geothermal well in Taiwan in past 5 years was done by me. So I think I can, confidently say like our technology can be helped to like not just CPC or like a GSMMA, but all the stakeholder in Taiwan. So as you can see, we have a FMI, like a borehole image log. It's like 4 direction with caliper, and each arm we have like 24 buttons to cover like around 80% for 8.5-inch open hole. So it's quite good. You can adjust this caliper size based on different hole shapes, and like sometimes if you have sometimes you have a big washout, or like the hole shape is kind not roughly, so it's a good technology to run in the like geothermal wells in Taiwan. Aside from that, we have a Sony scanner, which is like an advanced dipole. We can provide a monopole dipole and also Stoney waves to cover the well bore. So together with our FMI and Sony scanner, we can provide our advanced technology by our digital teams. So why it's important, like as this slide showing, we have a lot of fracture in the geothermal zone. But how can we identify this useful or not, right? This is quite tricky because you can see from the figure, like even though like if you drill a well, you can have an induced like fracture caused by the drilling, right? So how can we identify that it's useful or like is already the fault zone already there? So first of all, we pick up the all the dipping from the FMI image, and then we can identify together with the Sony scanner Stoney waves. So combined with this FMI and Stoney, we can telling you like okay, this is from here. This is the like actual fault zone which can with penetration. So this is quite useful for all the like a geothermal, especially the new field in Taiwan. So in short, like if there's like not much data in the new geothermal zone or like geothermal area we're going to be explored, exploration, we suggest to run this FMI Sony scanner together to make sure you find the correct zone, because as we know, like most of the geothermal fields, our target is to generate the power, right? So to make the generation like more economic, we need to know which zone is like the perfect zone to generate like to produce the water, the hot fluid. So this is very important for the stakeholder here, like potential stakeholder here in Taiwan.
Yeah, thank you, Chian. And this is like some fracture analysis conventionally done, but we can do more. Like how we can do. Like this is another application using sonic data. Like basically we use sonic same tools, same measurement of same tools using same for sonic measurement. But this sonic logging is actually also measuring some long duration of listening time. The meaning like we not only have a directional wave like a P wave, P wave, S wave, but we have actually like a reflection wave is also recorded by having this tool. So in this means that we measure the sonic waveform can be analyzed like a similar manner of like a surface seismic data, such as like a migration and then eventually imaging. So we can observe some like a reflection wave from this sonic waveform field, like a P2P or P2S or S2S and SNP. But there are like 4 total modes. That reflection wave is can be is majority is basically reflected by fracture if there is some natural fracture there, right? So meaning like this measurement of this reflection event, meaning we can mapping out where fracture it is, even like a far field. So this like depth of investigation or area to investigate it is actually far. It's big compared to, conventional logging. So this is actually up to like 50 meters from wellbore. That is, amazing achievable, by having this, 3D far field sonic. And the other approach to be considered is, geomechanics. I think we have a massive presentation about geomechanics, maybe in later today, this morning. But I like to also brief about how this, geomechanics approach also works to evaluate, fracture. So having like, core data, drilling data, or other, basic log data, especially density, and plus together with sonic data, we can, analyze a mechanical earth model, like a geomechanics property of the formation every single depth, meaning like a rock elastic property, rock strength, and pore pressure. And by having this model every single depth, we can apply geomechanics application, such as like a drilling wellbore stability, which is good for drilling engineer here. Also like a fracture stability analysis. So this is, more crucial for fracture analysis. Why? Because, as Chance, explained, few slides before, by having like a borehole image log, we can observe like a fracture cutting across the borehole, right? Just near wellbore. But the real challenge is from here. Now we have, borehole image log, but too much, too many we can observe. But what we want to know is which fracture is really effective, really permeable, right? This is, real challenge, after you get the data and start processing. So this is, like a nice approach, amazing approach, from a geomechanics analysis. So we have, a lot of fracture picking up by, like a borehole image log. And from, geomechanics, we can know about, stress direction and stress field. So you can imagine that you have a fracture path, and then you press vertical. This fracture is there, but it's stable, right? It doesn't move. But if your fracture is, is steep line like this, if you push vertically, this fracture can be slip, right? Which is we call unstable. So we analyze, stable fracture or unstable fracture together with fracture azimuth and dipping, as well as, stress field. We can understand, which fracture is unstable, most likely open, right? That is, most likely this fracture is only can make the feed zone for geothermal, right? So today, we are, presented about the different type of, fracture analysis, but it is very important integrate together to find out one, answers, right? That is basically reducing of the uncertainty. Just if you rely on just one measurement, one way to approach, you have some, a lot of uncertainty. But if you have, multiple approach, multiple, measurement, we can narrow down into one answer. So that is, that is what we do in geothermal, reservoir characterization. And this is one of the case study from Japan. So this is, geothermal, hydrothermal, geothermal, exploration wells. The depth is around, 2 to 3 kilometers. And we take, borehole image log and advanced sonic log and density. And we analyze, fracture picking from image log. And then you see, you have a, borehole geologist could give a lot of, like fracture. Oh, where is, fracture is permeable? She don't know, right? Now, we have, sonic and density. Okay, now, okay, we can analyze like a fracture strongly, or like we have actually, few reflection wave here. Okay, based on this data, some, the fracture is, like here and here is most likely, fracture aperture is high and then permeable, right? Then now, we also apply geomechanics modeling, like, rock strength, elastic property and stress field. Then by having this, fracture azimuth and dipping, then we can, classify, which fracture was actually unstable, most likely open, right? Then, we can, eventually we can narrow down, this 3 zone is, the more primarily, generate the feed zone. Then from, consider with, drilling parameter, then we have like a mud loss is like nearly here. Then, okay, that should be corresponding to here. And then if, secondary, thirdly, if operator want to complete, we can suggest this is second part and so on. And just a, case study I want to share today, this is also from Japan, geothermal exploration wells. we in this wells, we log like image log and advanced sonic log in dipole sonic, and then this is first time attempt 3D far field sonic measurement and analysis in geothermal well in Japan. So we take our data and then we process and then migration and then make an image. Then we can imaging like 60 meter even from well bore. And then you see that in a very clear reflection event, and and then this is basically measurement and result, right? And then by having together with fMRI, borehole image log analysis result, so we interpret this. This is basically like a fault, and the previous fault composed by like ancient ancient era fracture. So currently this fracture is actually filled up, but this zone is basically fracture zone generated in ancient era. But right now this fracture unfortunately already filled. So it didn't really connect to real permeable zone in this well, but we could do nice imaging using this sonic log data. So this is what I and Chian want to present it today more technical. But in Taiwan, as Tito presented case study from several fields, we have very very long history with a national oil company here in Taiwan, more than 40 years, and Chian is here. And now we have another success milestone in Taiwan actually. So this was very very new news here. So the day yesterday before, we had like a MOU signing with NCKU here to accelerate more our contribution to geothermal development in Taiwan, and this is very very tremendous achievement to open new era for new history for SLB Taiwan to support your geothermal project. So this is a very fast success case out of NOC, but we are open to if you have any if you have any other project you want to collaborate with us, please please feel free to reach out to us. All right, so that is conclusion. So basically today we present about how formation evaluation in geothermal and go through the few case study from Japan, and we are looking forward to work with you in near future. Thank you so much for your attention.
Thank you both so much for sharing some of the best practice of using fracture analysis.